in our notebook. So it says how many liters of a 25% antifreeze solution should be added to 5 liters of a 10% solution to obtain a 15% solution. So again, we have a lot of information here, so that chart is going to be very helpful to us because we're mixing two different things and getting a total. Now, I told you that labels on this table are important. That's what counts as defining your variables. So if you don't label what your columns and rows are, then you haven't defined your variables for me. What formula did we talk about using for this? What formula was written across the top of our table? Amount. Okay. My rows. What two things am I mixing together?
Mixing 25% and 10%.
Okay, so I'm going to call these 25%, 10% of my total. You can actually get this without even reading the problem. If I just look at my percents, if you think about those, your total has to fall in between the other two. So you're going to mix your highest and lowest concentration to get something in the middle. So for instance, if I said, if you had a problem and you saw a 70, a 24, and a 6, can you tell me which one would have to be the total? 24, because it falls in between the other two. If I said you had a pure, a 50%, and a 70%, which one has to be the total? The 70%. So when you're looking at these concentrations, you're going to mix your highest and lowest to get something in between. All right, so it says how many liters? Your amount, that's like your liters or your gallons, whatever the case may be. Concentration is like your percent. So when I start out with how many liters, I don't know it. So the number of liters of my 25%, that would just be X. Should be added to 5 liters of a 10% solution. So how much of my 10% do we have? 5. All right, my concentration, 25%, my concentration would be? Yeah, 1/4 of 0.25, either one. 10% would be 0.1. And my grand total, what concentration are we getting? 15%, so 0.15. All right, so if I poured in X of my 25% and 5 of my 10%, how much do I have in my grand total? Well, my concentration is 15. What would my amount be? If I had X of the first and 5 of the second? 5 plus X. You add them together. And so now, we really just follow the formula. Amount times concentration. So X times 0.25. 0.25X. 5 times 0.1. You can go ahead and multiply it if you want. 0.15 times my 5 plus X. how do we write the equation from there? When we talked Friday, I told you if you have this column, you really have everything you need for your equation. What do we have to do? Right. This is how much antifreeze you had in the first one. That's how much in the second one. This is the total. So you add the two to equal your total. So then we multiply it out. Combining like terms, if we subtract over the 0.15, we get 0.1x. If we subtract over the 0.5, that's 0.25. Divide by 0.1, and x is maybe you need to grab a calculator so you can participate as we go along. All right, and then what do we have to do at the end? Write a sentence. So the question was, how many liters of the 25%? And if we look, X was the amount of my 25%. Remember, I told you, you always have to have that sentence at the end. And I want a full sentence. Don't just say 2.5 liters and box it in. I want you guys to read the next problem and see how far you can get in setting up your table. So I don't want you to try to write the equation and solve it yet. That way if we make a mistake in the table, we'll fix that first. But see if you can make a table for this every time when we're doing these. Mm-hmm. Your amount, that's like our liters in this case. Concentration, that's always the percent. What am I mixing together?
Water and 18% X. For the water, could you put 0%?
So it starts out, how much water should be added to the 18%? So I know I'm mixing together my water and 18 to reduce the concentration to 15%. 15 is what I want in the end. So, water. If you go get a drink out of the water fountain, what percent acid is that water? 0. What my 18, what would I put for my concentration? 0.18, and my grand total is 0.15. So remember, I told you, the final one should always be in between the other two numbers. Is 15 in between 0 and 18? Yeah, so we know we have it set up correctly. So it starts out, how much water? So if I don't know it, that is my X. should be added to 20 liters of the 18%. So I have 20 of my 18. To reduce the concentration to 15%. So if I added in X of the first and 20 of the second, how much do I have at the end? X plus 20 or 20 plus X, either way they're the same. So if I multiply, X times 0 is 0. My 0.18 times 20 and my 0.15 times X plus 20. So then we know the equation, it just comes from this. What do we have to do? Every time. What have we done in the last two? Add the first two to equal our total. So 0 plus my 0.18 times 20 equals my 0.15 times X plus 20. Okay, multiply 0.18 times 20. That's 3.6 equals 0.15X plus 3. Subtract our 3. Divide by 0.15, and X is 4. So the question was, how much water? X was my amount of water. So there should be 4 liters of water. Bless you. Questions on that one? All right, this is one I took off the food science contest team questions a few years ago. It was one they brought in a practice test for me to help with, so I stole the question. See if you can set that up. All right, so when I'm reading this, when I start seeing all these percents, I know what's going across the top. Okay. You have a 30% cream and a 3.5% milk. Our target is 7%. So which two am I mixing together? When you mix the 30 and the 3.5 to get our total. Our target is our total. Plus, we can check 7 is between 30 and 3.5. Your grand total, that concentration has to be in between the other two. All right, since this is a test batch, you will be making an 8-pound batch. That means we are going to have 8 pounds at the end. So where does that go? The amount of my total. So in this problem, the amount is measured in pounds, but it's my total that I gave you. So a little bit different. 30% would be what concentration? 0.3. 3.5% would be And my total was 7%, so that is,
0.07.
I have to figure out what goes here. Can I just say these are both X? No, because I never told you I put in the same amount of each, so we can't do that. Now, can I make one of them my X? Absolutely, so pick one. Alright, so now we have to think. The strategy we've been using is you add your first and second to equal your total. We've been doing it here and in the final column, and that's still true, but this time I gave you my total. So if I had put in 2 of the first one, how many pounds would I need of the second one to get 8? 6. How'd you get it? You subtracted 8 minus 2. If I had given you 3, then how many more pounds would we need? 5. Because you do 8 minus your 3. So this is going to be 8 minus X. It's the grand total minus the amount we've already used. Check. If you add X and 8 minus X, does it equal 8? Yeah. So it's still following the same pattern. You add your first and second to equal your total. So now, if we multiply 0.3 times X is 0.3X. 0.035 times 8 minus X. And 0.07 times my 8. An equation every time you add your first and second to equal our total. So 0.3x plus 0.035 times 8 minus x equals 0.07 times 8. All right, 0.035 times 8. Point 0.28. 0.07 times 8. So 0.56. 0.3 minus 0.035. 265x. Subtract over my 0.28. Alright, and then when you divide, does it work out nicely this time? No, it is not a nice whole number. You can, put it as a fraction. It's kind of ugly. So it's 1.0566, or as a fraction, 56 over 53. If you're doing food science contests, they always tell you to round things at the end, so they would have a rounded version of this decimal. So the question asked us, how much cream? So if I look back, 30% was my cream, and that is what I labeled my X. If I had asked for how much of the milk, I would have to do 8 minus my answer. Any questions here? I am going to do one final problem for today. So last example of the day, and then we'll pick up with this again tomorrow. Sarah has $70,000 to invest and requires an overall rate of return of 9%. She can invest in a safe government-insured certificate of deposit, but it only pays 8%. To obtain 9%, she agrees to invest some of her money in non-insured corporate bonds paying 12%. How much should be placed in each to achieve her goal? Okay, I kind of changed course here. This is not necessarily a mixture problem, is it? But do we still have a lot of different things going on? So what do you think we're going to do first? Make a chart. Yep, so start with your chart. Now my formula across the top is going to be different because I'm not talking about amounts and concentrations. I am looking at what here? Can you tell me what this is going to be finding? You're investing money and getting a percent back. We're talking about our interest, aren't we? Do you guys remember how to find the interest?
Let's do 1 point.
You can do that to get like your ending amount. In general, it's principal times rate times time equals interest. I equals PRT. Does that sound familiar? Have you seen that before? This is simple interest. We'll talk later on in the year about different kinds of interest that we might find. But the only problems I'm going to give you right now is simple interest. P times R times T equals I. So every homework question tonight is either going to be a mixture, amount times concentration equals amount pure, or I think the very last one is an interest, principal times rate times time. So those are going to be my columns. P times R times T equals our I. Okay. So she wants 9%. So she is going to put some of it in her safe certificate of deposit that pays 8% and some in bonds paying 12%. Again, you can look at your totals or your percents. You know the total one has to be in between the other two. So we're going to have our 8%, our 12%, and our total, which is the 9. Okay, so if it's 8%, what's the rate? 0.08. 12% would be 0.12. 9%, 0.09. She has $70,000 right now. Where would that go? Is that the amount of 12%, the amount of 8%, or the total? Total. Is it the interest that we've earned, the time, or the principal? Principal. How much we have to start with. Okay. We want to know how much to be placed in each investment. Do I know how much she's putting at 8%? No, so that would be X. What would I call the other one then? If I put 30,000 in the first one, how much goes in my second one? Just flip it. Total minus X. So 70,000 minus X. Did I make any mention of time here? How many years I'm investing? No. So if I don't tell you otherwise, just do 1 year. So then we multiply. X times 0.08 times 1, 0.08x. This one I would have the 0.12 times my 70,000 minus x. By 1.09 times 70,000. This is the amount of interest I get for my first one. That's the amount for my second one and my total. So you add the first two to equal your total. .12 times 70,000 would be 8,400. Everybody still with me here? So, Sarah invests 52,500 at, that was my X was my 8%. And how do we find the amount at 12%? Look up to your table. Yep, 70,000 minus 52,500 is 17,500.
What is the, on the top, the very top row of the equation? No, not left, or where we can see. Why is there a minus one, two?
Because this was a minus X. So when you distribute a negative times a positive. Alright, tomorrow we will begin class with another one of these interest problems, and we will probably wrap up our notes on this because the other problems after that are pretty short and sweet. You guys should have done 1 through 4 on that handout already, so remember it was a handout posted on Classroom. Today, I want you to add 5 through 8 to that assignment. So you can do it on the same sheet of paper. We didn't turn in the first 4 questions yet. So now you're doing the next 4.